I took on the impossible challenge, make a whole V8 engine from scratch. Will I succeed or will it explode, leaving me absolutely devastated? Nothing's for sure, but one thing I know is that this is not going to be easy, and you're not going to want to miss it. Let's take a look at what a V8 engine really is. The V8 engine was introduced for aircraft in 1905 and became popular in cars with Cadillac's 1914 version. Ford revolutionized the market in 1932 with its affordable flathead V8, making it a symbol of American muscle cars like the Mustang and Corvette. While more fuel-efficient engines have emerged, the V8 remains valued for its power and performance and luxury vehicles. Since I'm going to be trying to 3D print it, I found the files for free at Printables, link in the description if you want to check it out. After downloading the 6 files, I opened them up in Bambu Studio since I'm printing with my Bambu Lab A1 Mini. From there, I saw that some of the pieces didn't fit my build plate, so I sized the pieces down to 90%. And a crucial step here was when you size down one piece, you have to size down all the pieces to ensure that none of the pieces are too big. Because if one piece is too big, then the engine won't function. And I changed the infill to triangles to save some filament while still keeping the strength. As I said earlier, I'm printing on my almost new Bambu Lab A1 Mini. I've had it for about 2 months now and I've had no issues with it. It's small compared to other printers on the market and it's remarkably fast. For this project, I'm using black and red regular PLA and white PLA+. PLA Plus is great for projects like these where strength is crucial because it's stronger than regular PLA. And since I'm making this mechanism with moving parts, I added supports where it's needed to ensure success when printing. In projects like this, precision is very important when dealing with these moving parts, and I applied a thin layer of stick glue after every print to ensure that the prints don't leave the bed while printing. So why am I doing this, you might ask? Well, I'm doing it to prove that I make the most extraordinary 3D prints on YouTube. And if you have any idea for a crazy 3D print, then leave it in the comments and I might do it for my next video. This whole print took me 13 hours of printing, so make sure to hit that like button. But something was wrong. My printer was printing air. So I stopped the print, removed the nozzle and checked for any clogs in it. But there was nothing. So I tried loading the filament and it worked. But there was something wrong with the first proof. It was a little bit yellow on the start, but eventually became back to normal. And since I had to stop the print right before the print was done, I didn't want to throw a piece out, since I had spent so much time and filament to get it this far. So I cut where I thought the print ended, and I printed a test piece to see how much lower or higher I needed to cut. And the first time I printed the test piece, I accidentally made it way too small. So I printed it again and saw that it was actually pretty nice. Now let's print both and hope for the best. Moment of truth, will they fit? Yes, they do, finally, and it's time to start building this thing. First, we start by gluing the small handle to the crankshaft and attaching all 8 of the piston arms to it. Then we attach the red piston heads and fit them all in the top block. And I had accidentally broken one of the pins that hold the main pieces together, but no big deal. And before I spin it, one question remains. Will it all come crashing down once I start spinning it? Will these final moments of sanding be the last for the gearbox? Let's see. Yes, it's running great. And most importantly, it didn't explode in my face. This engine has 8 pistons that move in a unique pattern. This pattern is unique for V8 engines, and it goes like this. A V8 engine has 8 cylinders in a V shape. The V layout, usually 90 degrees, balances forces and minimizes vibration. The crankshaft design and firing order are crucial for smooth power delivery, and each cylinder goes through a 4-stroke cycle: intake, compression, power, and exhaust. The engine's firing order ensures smooth, continuous power, providing high performance and torque. And of course, this engine can't be used as a real engine, but it shows how great 3D printing is for education and modeling. Because for only $10 of filament, you can make a model V8 engine, which you can use in schools to teach people about these complex mechanisms. You can make anything with 3D printing, from model engines to other mechanisms which would otherwise cost hundreds to buy. In conclusion, I think that this was an interesting concept, and I'm looking forward to doing even crazier things in the future. So don't forget to hit that subscribe button so you won't miss out. And if you enjoyed the video, then smash that like button, and I'll see you in my next one.